Permutations with cases. Permutations with cases comes up when you can't count something all at once. And you guys have been discovering this with like brother, sister, brother, sister, brother, sister, or it could be sister, brother, sister, brother, sister, brother. And if you have two things that you count separately, you just add them up. And that's the idea with cases. When you can't count something all at once, you count it separately and just add up all of your separate cases in the end. So how many digits of, at most, 3 digits can be formed using 0 through 9? Well, this we can't count all at once. And with cases, we often write case 1, I'll count my 3-digit numbers. What restriction do we have if we're counting 3-digit numbers? Can't start with 0. So this is not 0 giving us 9 choices, then 9, then 8, for 648 in total. Case 2, two-digit numbers. Again, can't start with 0, so 9 and then 9, 81, and then case 3, and now we can get into a one-digit number. How many choices do we have? Is 0 a one-digit number? What do you feel? Yes? Okay. Then you'd have 10 choices. Some people argue, well, I can't include 0 again. Well, yes, you can. And then what we do with cases is we add these all up, which will give us 739. How do we recognize when something's cases? Well, sometimes you try to count it all at once and you keep running into problems when trying to count it all at once. And then you realize, okay, we have to break this up and count them separately. And often that comes when there's two restrictions on a question, like how many 3-digit numbers using only the numbers 1 through 5 greater than 300 than even. So you start with your spaces, 3 spaces, greater than 300, so that means this is a 3, a 4, or a 5. So you'd say, oh, there's 3 choices here. And then you say it needs to be even, so you put 2 and 4, so 2 choices. I've used up 2 numbers and 3. And you go and check your answer at the back of the book, and it's wrong. It's not 18. Why does this cause us a problem? Well, if you were doing this up on the whiteboards, I would say, well, in 3, 4, 5, let's say I chose the 4, and then here I chose the 4, and then here I chose whatever's left. What's the problem? Maybe I choose the 1 then. What's the problem with this number? It says no repetition, but we have the 4 twice. By making it a choice here and making it a choice here, we run into a problem. Because you could write 414 doing it this way. But the problem is you don't write 1 here. You can't just write a 1 there because you might not have chosen the 4 to begin with. So trying to count it all at once just doesn't work. So when we have restrictions that overlap, and that's what I'll say in this one, the 4 is in both restrictions, it kind of overlaps, we have to come up with a way of counting this separately. So, and there's a number of different ways to do this. We could do case 1 like this. Let's say I make my last digit a 4. Well, then what are my choices for my first digit? Then my first digit has to be a 3 or a 5. 2 choices, no restrictions on the middle. So there would be 6 ways to do that. Case 2. So case 1, end in 4. Case 2, what haven't I counted? I could end in the 2. That would still make it even, 1 choice, but now The first number could be 3, 4, or 5. No restrictions on the middle. Add them up, and there would be 15 ways in total. So as long as we count our cases separately and we keep going through, okay, how can I break this up to count it separately? If I do all the even numbers that end in 4, there's 6 of them. Then if I do all the even numbers that end in 2, there's another 9. And how you break up the cases is up to you. You could, when you're breaking up your cases, you're dealing with one restriction or the other. So another way that I could do this same question I could say, let's start with 4. Let's count all the 400s. There'd be one choice here. If it was even, how many choices would there be for my last number? 1, because it has to be a 2, and then no restrictions. So then I get 3 cases in the 400s. Case 2, what haven't I started with? Start with 3 or 5. And some people will do 3 cases. Start with 4, start with 3, start with 5. And that's not wrong. But I could start with 3 or 5 at the same time, because then my restrictions here, this can be 2 or 4, no restrictions on the middle, 3 numbers left, 12 ways. What happens when I add 3 plus 12? I get the same answer that I did before. And if you broke it up into 3 cases, start with 3, start with 4, start with 5. That's fine as well. So what happens is when we get these places where there's 2 restrictions and the restrictions conflict with each other, as they did here with the 4s, then you choose one of your restrictions and break it up into cases. And usually, I like to pick the restriction that has less things, like the last digit was a 2 or a 4, because that's easy to break up into cases. End with a 2, end with a 4. And then I know I've counted them all. But it's not wrong to start with the first restriction and break it up either. How many, again using 1, 2, 3, 4, 5, are greater than 232? So some of you got to this greater than question that was in the homework yesterday and were struggling with it. Why do we get a problem here? Well, if it's greater than 232, the first number has to be a 2, a 3, a 4, or a 5, right? Sometimes we think this is going to be wrong, but I'm going to do it as if I'm thinking about trying to do it all at once. And then we run into a problem right here. What number do I put in there? Well, if I chose the 2, then it can only be 4 or 5. Does that make sense? Well, it could be 3, 4, or 5. But if I chose the 4, it doesn't matter what's next. Because if I chose the 4, I could have 4 then 1. 415 is bigger than 232. So on these ones where it's greater than, what I suggest doing for your cases is start with a number that would guarantee, or start with all the numbers that would guarantee that it's going to be bigger than 232. So if I started with a 3, a 4, or a 5, does that make sense that that would guarantee that 300s, 400s, 500s, no problem, I'm going to be bigger than 232. So if I draw my spaces and I make this a 3, a 4, or a 5, 3 choices there, there's no problems. I can do anything, no restrictions. There's 4 numbers left, then 3, 36 in total. So what haven't I counted? Case 2, I haven't counted my numbers that start with 2, my 200s. So if I make my first digit a 2, there's one choice there. Now, with the second number, I'm going to do the same strategy I did in part 1. What would guarantee that it's going to be bigger than 232? Well, I'll count all my numbers in the 240s and all my numbers in the 250s, because there's still some problems with the 230s, because you can't have 231. And if it's greater than 232, well, you can't have 232 either, but there's repetition there, so that wouldn't ever count. So if I went then 4 or 5, two choices here, then there would be no restrictions on what's left. There was 5 numbers to begin with. You've used up 2, so there's 3 choices left for 6. And finally, case 3, what haven't we counted? We haven't counted the numbers in the 230s. Start with 2, then 3. If I start with 2 and then a 3, one choice for each of those, what are my possibilities for what's left? It needs to be bigger than 232, so there is a restriction on my last space. And whenever there's a restriction on a space, I want you to write numbers that you have for choices. Because the number one thing that happens in this last case that students do is they just go, oh, well, it needs to be bigger than a 2, that's 3, 4, 5, there's 3 choices, and they write a 3 without thinking. What's the problem with choosing a 3 there? I've already used the 3 in my 3, 4, or 5. In fact, my only choices that are left are 4 and 5. To be bigger than 2, you can't have 3, it's already gone. The only choices that are left are 4 and 5, so I write them down, 2 choices, 2 in total, add them up, 36 plus 6 plus 2, 44 numbers in total. And that is our last example.